Let's build a functional REST API from scratch using Express.js. This mockup shows our target, a system where sending a request triggers a task-created success message, confirming the backend is processing data correctly. To follow along, make sure you have Node.js and Express installed, alongside the Postman application. Using a tool like Postman bridges the gap between writing raw server code and actually interacting with it like a real user. First, initialize your Express server in an index.js file and set it to listen on port 3000. This code editor mockup highlights the JSON middleware. You need this specific line. Without it, your server won't be able to parse the data you send to it later. Once the code is saved, check your terminal output. A server running message confirms the initialization is successful. We'll start with an in-memory database, a simple JavaScript array populated with a single default task. Now, go create your first GET route. This acts as the pathway to read that array and return it to whoever requests it. In this Postman interface, we select the GET method and target our local host URL. The default array appears right here in the response window. When you hit send, it triggers the route you just wrote and returns that JSON data to the client. Seeing that data in Postman proves the server is working, ready for more complex requests. To add new entries, we use the post method. This route is specifically designed to take incoming data and push it into our existing array. On the server side, your code needs to capture the request body, assign a new ID to the task, and append it to the list. In Postman, toggle the request method from GET to POST to test the new logic. To format the outgoing data, follow these steps in Postman. Click the Body tab, select the Raw Radio button, and use the dropdown to set the format to JSON. If you forget to switch from text to JSON, the server won't understand the input and the process will fail. Send a request containing a new task object. You should see a success message in the response window. To verify it worked, run a GET request again. The array should now contain both the original task and the one you just added. Successfully running this POST request shows that your server can now update its own state based on what the user sends. Next, we will build a PUT route. This method is used when you need to target and modify an entry that already exists. This diagram shows the logic. We use a dynamic ID in the URL to tell the server which task to change. Once it finds the right ID, it overwrites the old data with your new input and sends a confirmation. In Postman, select the new PUT method and append the ID of the task you want to change to the URL. Send the updated task data in the body. The server should respond with a message confirming the change. Check the data one last time with a GET request. The old string should be gone, replaced by your new update. With GET, POST, and PUT correctly working, you can now retrieve, add, and modify the data in your collection. You've successfully built a working API that can handle the core requirements of a to-do list. But because this data is stored in a simple variable rather than a real database, it is temporary. If you restart your server or the application crashes, every new task will disappear instantly. While your API logic is correct, keeping this data permanently requires connecting your code to a real database, which is exactly what we'll do in the next.